Hi everyone, this is Mwesigwa Joshua, and I'm presenting a proposal titled Explainable Artificial Intelligence and Deep Transfer Learning for Skin Disease Diagnosis. I'm a part of Group 19, and I'm affiliated to Makerere University, Uganda. I will start by walking through the contents of the presentation. I'll start with the introduction and then the problem statement, and then work my way towards the methodology and then the future works. Uh, As part of our proposal, most of our work is revolved around the concept of diagnosis. So what is a diagnosis? A diagnosis can be defined as any form of treatment that an individual would get or receive from a medical personnel or an artificial agent. And it is very important that we, as people who are trying to understand the problem of diagnosis, it is very important for us to get the diagnosis is accurate, because accurate diagnosis as it emerges, it can save a lot of problems in this context, and more specifically towards the context of skin diseases, it can save a lot of issues. Basically, skin diseases in particular have emerged as one of the most problems that people face in the global context of health, and accurate diagnosis is very vital if we are to tackle this problem. To talk more about what the problem that we are trying to solve here, skin diseases cause a huge global burden in the context of global health, and they contribute as majority in terms of widespread human diseases in the world. Uh, most especially if we're trying to talk about misdiagnosis, what could misdiagnosis lead to? Misdiagnosis could lead to outbreaks. It could lead to prolonged patient suffering. It could lead to death. It could lead to wrong prescriptions given to patients by doctors. More talk about the outbreak point. Take an example of COVID-19. If we had a diagnosis framework or a detection framework at the start of this outbreak, then we would have been able to prevent the outbreak. But since there were no detection frameworks, there were no diagnosis frameworks, that's how we ended up with the outbreak in the first place. So this shows you how important diagnosis and accurate diagnosis in particular is very important if we're trying to talk about skin diseases. The problem tree here describes in detail our problem statement. You start from having time-consuming extensive tests, and then you have the diagnosis being tied up to the dermatologist is expert. How competent is he? And then if that person is not very well competent, or if they're just starting out, that's how you end up with a misdiagnosis. And then a misdiagnosis will lead to prolonged patient suffering. It will lead to anxiety among patients. It will lead to confusion among patients, misprescription of medicine, which could even lead to death and other prolonged infections or diseases. Our research scope, we are trying to look at 10 classes, 10 skin disease classes, and the way we are trying to tackle the problem, or part of our solution, will include using explainable artificial intelligence. And to be specific, we shall be using GradCam, where we shall be looking at the activation maps and then the pixels that the model is using to make different predictions. We shall be using deep transfer learning, the concept where we get knowledge learned by a model from a given field and then use it or apply that knowledge to solve problems in a related field. We shall be using convolutional neural networks because they have proved to be very, very vital and very efficient in solving problems that are related with image classification and image identifying features in images. That will be the scope of our research. To talk about the literature review, a lot of research has been carried out around skin diseases and skin conditions. RRA, in their research on skin disease control principles in developing countries, they found out that over 1.9 billion people are being faced with this problem of misdiagnosis. Like, you find out that 1.9 billion people are misdiagnosed when they head out to get diagnosis from doctors in developing countries. And then reports from the National Center of Biotechnology show that the cost of treatment for people with skin cancers and skin related diseases is over $1 billion. That's a lot of money. In addition to that, the World Health The World Health Organization has carried out some research in the recent years, and it shows that diseases that are burdensome worldwide, and their analysis shows that most of these diseases are skin-related diseases. Our research questions include how can deep learning be used to improve predictive accuracy in diagnosis of skin diseases in particular? How can we deploy the explainable artificial intelligence techniques to explain the predictions that will be made by our models? And then how can we implement those techniques in particular to the skin diagnosis problem? Our research objectives will be to produce a model that can help or that can aid that can help dermatologists quicken their diagnosis times. It will also aim at producing an evaluated model. We want to test and evaluate the model through our research. Then we want to deploy the interpretability techniques onto this model to be able to explain its predictions. And then as a result of that, improve the adoption of artificial intelligence in this field. Our research contribution is tied up to the fact that diagnosis currently is tied up to a lot of constraints, and these constraints include you have the dermatologist's expertise. As a result, some of the times you have inaccurate tests. Due to those inaccurate tests, people are being given wrong prescriptions at times. Then the expertise of you probably don't have you don't have to we want to create a world where all these constraints don't need to affect a given diagnosis, and we shall do that by creating an orchestration or creating a very trained and intelligent model that can detect, provide quick and faster diagnosis without all these constraints coming into play. Our methodology is tied up to concepts around deep learning, convolutional neural networks, transfer learning, and explainability techniques. Deep learning is it's a field where we train a model to understand based on some given data and then be able to explain those techniques using techniques such as GradCam, LRP, and GraphLine, and much more techniques that I explained now proposing. Recent research has shown that convolutional networks work very good when it comes to problems of classifying image data, and therefore we shall be using VGG16, which is a state-of-the-art model to explain to help us in trying to learn features that are very important or to classify these skin disease classes with our model. In our model, this is a brief methodology, or this is a high-level overview of our model or our system architecture. It will start with an input image that will be passed through a pipeline of preprocessing techniques, that is resizing, augmenting to increase the data points. And then we shall pass this data through VGG16, and on top of VGG16, we shall train a feature extractor. We shall freeze the layers of VGG16 so that we don't retrain them, but we shall retrain a feature extractor on top of this so that the model can be able to extract the features that are important to the skin classification problem. After that, we shall perform some training and predictions, and then we shall use explainability techniques to explain these predictions that are being made by the model, or these diagnosis outcomes that are being provided by the model. Our research timeline is as follows. We shall carry out a number of tasks. I'm trying to run through so that I catch the time. And I'm going to just say that these are all the tasks that we shall be carrying out, most importantly being training the model, preprocessing the data, and then implementing the explainability techniques in Python. The start times and the end times are as follows. We hope to be done with the project by May so that we can be able to demo it to the panel. Expected outcomes. The major expected outcome of our research should be a fully trained, evaluated, and tested deep learning interpretable model that is capable of diagnosing skin disorders. It should be capable of differentiating among the 10 classes that we listed in our scope. And as a result of that, we want to have an implementation of GradCam that can be able to help us explain the predictions and the classifications of our model. For example, if the model is saying that this is acne, then it should give us it should give us the feature maps that show which pixels in this exact image were responsible for the model saying that this is acne. If it's saying that this is melanoma, then it should probably give us active activation maps, pointing out which pixels probably they should be around this patch here to show that, okay, this is what the model based on to say that this is melanoma, or to classify the diagnosis as melanoma. Part of our future work includes that we want to implement more explainability techniques and then contribute to the open source world, because we made a lot of research and we couldn't find a lot of implementations of some of these techniques. So we want to maybe in the future implement some of these techniques and as a result triangulate our explanation. So we should be able to provide an explanation from from LRP, from GraphLine, from GradCam. We should be able to triangulate that, predict the explanations of our model, not limited to only one explainability technique, but to other techniques. And then we also want to design an ecosystem where we can bring together different dermatologists from different parts of the world or from different backgrounds, and then be able to create an ecosystem where they can come and then bring more insight on how we can probably elevate this model and how we can enhance it and make sure that the model becomes better at what it does. Because ultimately, we're trying to improve the adoption of artificial intelligence in the field of health. And as a result, we need to be able to take care of the people who are going to use this model. We need to be able to incorporate them in the whole process. So part of our future work will be that after we have provided a model that has been trained, that is explainable, that can provide accurate diagnosis in a very short in the shortest time possible, then we should be able to deploy this to an extent where someone can use it and then get a given diagnosis in a very short limited time. And then after that, just like we mentioned in our research objectives, we should be able to explain those predictions to a given individual. Let's say like a dermatologist should be able to see that, okay, this is what the model based on to say that this is this. And then what we're trying to say is that after all that has happened, we want to design an ecosystem where we can now bring many dermatologists on a platform and even provide more data that we can use to retrain and refine the model. We should be able to bring to probably have a forum where these guys can discuss the predictions that were made by the model. Let's say if they are satisfied with the results, and if they're not, they should be able to provide us with some feedback that we can use to refine tune the model, much like what is being done with GPT right now. People are providing feedback, and then I'm sure that the designers will be able to use this feedback to refine the model so that it gets to a better place, to a more adaptable place, or to a more adaptable what's the right word, to a more adaptable, acceptable area, you know. Yeah, so thanks for listening.